What I want to talk about here is a concept called the Euclidean algorithm. Now, the Euclidean algorithm is an extension of the division algorithm. And what it does is its aim is to look at a pair of numbers and determine the greatest common divisor of these two numbers. And it uses a set methodology in order to do this, and the fact that numbers take a set format in order to be able to do this. So this mathematical strategy, it applies the division algorithm in order to be able to do this. Now, as I mentioned, it's about finding the greatest common divisor of a pair of given numbers. We denote this in this manner: GCD bracket A, comma B, where A and B are the given pair of numbers. So it could be find the greatest common divisor of 56 and 40. Now what we do in order to do this is we repeatedly subtract the smaller number from the larger number. The remainder then becomes the divisor of the next line, and then we continue to go on and on until we get a remainder equal to 0. From this, we can discover the greatest common divisor. Now, if the greatest common divisor is 1, we will get to a point at the end where all we are left with is 1 and no remainder. So it will work its way to that. But if we're left with something else with no remainder, that's when we can get our greatest common divisor. Now, there's a set of steps to this methodology that just makes it a lot easier for us to follow and helps us to apply this technique in an effective manner. What we do is we follow this 4-step technique. Firstly, we express the higher of the two numbers, again that's called the dividend, as a product of the smaller number, the divisor. So taking the format from the division algorithm, we set it into a format A equals QB plus R. So A is equal to the quotient Q times the divisor plus some sort of remainder. What we then do is we take this and we take that divisor and express it as the new dividend, and then that remainder becomes the new divisor. So if this one here is how it looks, our next line, our new dividend would be equal to B. We'd have some sort of new quotient, which we'll call B1, and the remainder from before actually becomes the divisor. And I'll end up with some sort of new remainder. Let's call that R1 for argument's sake. What I then do is I continue to repeat this set of steps until I get a remainder that equals 0. Once I have a remainder that equals 0, we can identify the greatest common divisor of the pair of numbers that we originally started with. So we're continuing to divide down until we have something that has no remainder. Easiest way to demonstrate this is with a couple of examples, which I'm going to show you now. Let's address the question, find the greatest common divisor of the numbers 48 and 18. So what we want to do is firstly express 48 in that standard format we get from the division algorithm, and then start to work our way down until we end up with a remainder of 0. So expressing it in that standard format, we know that 48 is going to equal something times 18 plus a remainder. So we have to figure out that something, the quotient that we're going to do. Well, 2 18s, that's 36. If I then make 3 18s, that's 54. So that's too far for us to go. So I'm going to say that it's 2 times 18, so it's 36. I've got a remainder. My remainder is 12. So that's our first step there. What I then have to do is I take my divisor and I express that as something times a new divisor, which is going to be given by the previous remainder. And then it's going to be plus some sort of remainder. So you'll notice the divisor from line 1 becomes the dividend here, remainder becomes the new divisor there. And then I approach it in the same manner. So 18 equals something times 12 plus something else. Well, what we have to do is it's 1 times 12, because remember, we have to be below the number we're looking at. So it's 1 times 12 plus a remainder, which in this case is 6. So the remainder's not 0 yet. We continue and we go on to another line. Next line, that becomes your new dividend, so 12 equals, the remainder becomes your new divisor, something times 6 plus a remainder. Well, we know 12 is 2 6s. So it's 2 times 6 plus my remainder. In this case, my remainder is equal to 0. So because my remainder is equal to 0, this divisor here at the end is my greatest common divisor of the pair of numbers 48 and 18. So what I can then say is the greatest common divisor of 48 and 18 is equal to 6. So it's the greatest, the highest number that divides both of those. Yes, there are other numbers that divide into them and that are factors of 48 and 18. For example, 2 is another one. However, it's not the greatest common divisor. It's just a divisor of the pair of them. This set of steps, followed every single time, will always get us there. We may need to do it 2 or 3 more times. We may do it only once. It all just depends. We just have to keep repeating it until we get that remainder being equal to 0. Let's do another example. So highest common divisor of the numbers 95 and 7. So again, start off the same manner. Express 95 in something that's a standard format similar to the division algorithm. So something times 7 plus another number. That other number, remember, that's a remainder. Now if we think about it, if I do 13 times 7, that'll give me 91. If I do 14 times 7, that gives me 98, which is too far. So I know I'm going to be able to express it as 95 equals 13 times 7 plus a remainder, and in this case the remainder is 4. So there's still a remainder there. Let's do it again. Remember, the 7, a divisor, becomes a new dividend. The remainder becomes a new divisor. So it's going to be something in that format. 7 equals something times 4 plus a remainder. Now that something is just 1. Then my remainder is 3. Again, we still have a remainder. Let's continue. Again, same steps. Divisor becomes a dividend. Remainder becomes a divisor. So 4 equals something times 3. Well, 1 times 3 plus a remainder, which is 1. Still have a remainder. We continue on with the next line. We know it's going to be 3 equals something times 1 plus a remainder. Well, 3 times 1 gives me 3, and there's no remainder there. Now, what does this mean here? Well, this means that there is a greatest common divisor. So from this, I'm able to say that the greatest common divisor of 95 and 7 is equal to 1 in this case. There are no other factors that 95 and 7 share. You've got to remember, 7's a prime number, so 7's only factors itself anyway are 7 and 1. So the factors of 95 that are the greatest common divisor of 7 are either 7 or 1. Has to fall into one of those two categories. So there we go. Sometimes our greatest common divisor is actually 1 itself. They don't share any other common factors. For this one, we want to find the greatest common divisor of 3 numbers this time. So 60, 96 and 140. Now for this one, we can't just fire all 3 of these together in a single division algorithm and figure it out from there. What we have to do is look at each pair of numbers individually, figure out the greatest common divisor of all 3 of those numbers, and then we take the smallest of the greatest common divisors, and that gives me the overall greatest common divisor of the 3 numbers. So let's start with 140 and 96. So I want to look for the greatest common divisor of these 2 numbers to begin with. So let's make this our first step. So again, look at our standard format. So 140 is going to equal something times 96 plus a remainder. Well, it's going to equal 1 times 96. Then I've got my remainder, which is 44. Still a remainder there, we do it again. Now we say, right, 96 is going to equal something times 44 plus a remainder. Well, it's going to equal 2 44s, which will give me 88, plus my remainder, which is 8. Still a remainder, we go again. So I know 44 is going to equal something times 8 plus a number. Well, 5 8s are 40. So if I do that, and then I've got a remainder of 4. Still a remainder, let's go again. I know that 8 is going to equal something times 4 plus my remainder. Well, 2 4s are 8, there's no remainder. There you go. So my greatest common divisor of 140 and 96 is equal to 4. Then we look at another pair. So let's look at the greatest common divisor of 140 and 60 now. So again, we follow the same set of steps, except this time 145 is my initial dividend and 60 is my starting divisor. So all we do is we begin with two slightly different numbers. We still follow the same set of steps every time though. So 140 equals something times 60 plus another number. Well, it's 2 60s because that's 120 plus a remainder of 20. I then do my next step. I say, fine, 60 is going to equal something times 20 plus a remainder. Well, 60 is just 3 times 20 plus a remainder, but in this case my remainder is equal to 0. So actually we've done it in one step for these two, and we're able to say then that the greatest common divisor of 140 and 60 is going to equal 20. We've now got one final pair of numbers to look at. We want to look for the greatest common divisor of 96 and 60 now. So this final pair of numbers. Again, the same set of steps. 96 is equal to something times 60 plus a remainder. Well, it's equal to 1 times 60 plus my remainder, which in this case is 36. Still a remainder, we go again. So we say 60 is equal to something times 36 plus a remainder. Well, it's going to equal 1 times 36. I then have to add 24 onto that. So it's then going to be plus 24. Still a remainder, we still do another step. This time though it's 36 equals something times 24 plus my remainder. Well, 36 is equal to 1 of the 24s plus a remainder of 12. Still a remainder, still continue. Remember, we continue until that remainder is equal to 0. If we don't find the right answer. So again, something times 12 plus a remainder. Well, 24 is quite simply 2 12s. There is no remainder there. So what I'm able to say is fine. The greatest common divisor of 96 and 60, that is therefore equal to 12. So what I now do is I look at all three greatest common divisors and I say to myself, what is the smallest greatest common divisor in this set of calculations? Well, the smallest greatest common divisor is 4. One thing you'll notice is that 20 and 12 are both in the 4 times table as well. So they're able to be divided by 4. So 4 is a divisor of both of those. So that can be applied across the board to all three numbers. So what I'm then able to say is fine. That implies that the greatest common divisor of 140, 96 and 60 is equal to 4. Some of them share other factors, as we've just shown there, and other greatest common divisors, but the greatest common divisor of all three of them together is equal to 4. So we're able to approach it in that manner. If we had 4 numbers, I'd just look at another set of pairs of numbers. We'd have to do a few more, but again, it would still be the smallest greatest common divisor that we find for all of them. Applying this Euclidean algorithm is a fairly straightforward process. Sometimes it can be lengthy and take a few moments, but it's the same set of steps every time, and it just takes a division algorithm, the standard format from that, and applies it to a scenario in the search for no remainders. And that gives us greatest common divisors.